All right, so when we do talk about polar coordinates, this is when, again, you've got a two-dimensional coordinate system, but now in order to go from one point to the other point, you're not going to go horizontally over and then vertically up. Instead, right, if you start from this point here, what you're going to do is you're going to go radially out in a certain direction, let's say 3 meters, 3 units, 7 units, and then you're going to rotate by a certain angle and you're going to get to your point. Okay, so you go radially out and then you, let's say 3 units, and then you rotate 55 degrees and you get to a certain point. And that, again, those two sets of instructions will tell you exactly where your second point is going to be, right? So suppose I tell you to go out 2 units and then rotate 30 degrees right there. That's your point. So now, if I tell a pilot that, all right, that's a little bit more manageable, okay? All right, so since we have a new system, we have a new set of variables. In the rectangular coordinate system, our variables were x and y, x for horizontal, y for vertical. Well, we can't have that anymore. And remember what I said? I said in the new polar coordinate system, we're going to go out from a point. We're going to go radially out from a point. So we call that r for radius, and then I rotate through an angle theta. So no longer do I have x and y. Now my variables are r and theta. Okay? All right. So let's get used to this new space. This new space also has an origin. It's called a pole. So we're not going to say origin anymore. We're just going to say pole. Okay? The rectangular coordinate system has how many axes? 2. Here we have one axis. It's called the polar axis. And the polar axis is not like the x-axis that extends in 2 directions. It's a ray that extends in 1. So it's a ray. It starts at the origin and moves radially out. Okay? The polar coordinates are defined as r and theta. And we just said r is the directed distance from the pole. Theta is the directed angle from the polar axis. Questions? Okay, so how do we graph? Well, r is a value, right? We can have positive or negative values for r. We could have positive or negative values for theta. Okay, now let's talk about theta first. So how do we graph a point? If you have a positive value of theta, you go in the counterclockwise direction. So in math and physics, it's always, the counterclockwise is always positive. That's just how it works. Now, how about r? Remember I said the polar axis is a ray? So it only extends in one direction. That means if I have a positive value of r, right, I do my ray and my point is on that ray, okay? So suppose I say I want to graph something that is 3 units, so 3 comma 40 degrees, okay? What am I going to do? Well, this is the polar axis. I'm going to go out 3 units here. And then I want to rotate this an angle of 40 degrees right there, right? And that's where my point is. Does that make sense to everybody? Now, this is if I had a positive r. Okay, now, what if your r is negative? Well, if r is negative, so suppose now my r is negative 3 comma 40. So here's what I do. I go out, I rotate this 40 degrees. So where is my ray now? Right there, right? But if it's negative 40 degrees, you go in the opposite direction. You make an opposite ray, and your point is right there. Okay? It does do something. If R was positive, my point would be there.
But I thought you just said if theta was negative, then it would be down. So what is negative R? What's the difference between negative R and negative theta?
Okay, negative theta, I rotate this way. Right. Negative R is I rotate that way, and then I go like radially out in the opposite direction.
So should we, when we're drawing that, should we draw both of them?
Yeah, I'll show you right now how to draw them. So let me do these two examples, okay? Here, this is point S, and this is not 1,200. This is R is 1, theta is 200, okay? So we're going to get used to like that notation a little bit. So here's how we do it. This is basically the pole and the polar axis, right? Okay, now what I want is, it's easiest if you do theta first. So let's do theta first. Okay, what's 200 degrees? That's 180. 200 is somewhere around there, right? So there we go. I just draw that for myself. Okay? Does that make sense that that's a 200-degree angle? That's a little bit, did I go too far? I went too far. Here. Is that better? Okay. So that's 200 degrees. And now, how much is my radius? 1. So here, I go 1 out on my terminal side. 1 unit out. Right there. So that's my point. Now, I'm going to give you, this is how the grids will look. Okay, I'm just doing one in general now, and then we'll do a couple more on these. Okay? All right. So take a look at this one. Here I have the polar axis. Now I'm going to go with theta first. It's 3 pi over 2. That means it's going to be vertically down like this. Right? Now, if my R was 2, where would it be? On that blue line facing down. But it's negative 2. So now I draw the opposite ray. And I'm going to go 2 units up. 1, 2. There we go. There's my point R. Okay? And this first one was my point S. All right. So rectangular coordinates are graphed on a rectangular grid. Polar coordinates are graphed on a circular or polar grid. Okay, so this is it. And I'll give you a sheet of these. So notice how we label these, right? We label them by our special angles. 30 degrees, 60 degrees, 90 degrees, pi over 6, pi over 3, pi over 2. Okay? And if you were to graph, let's say, pi over 4, where would that be? That would be in between pi over 6 and pi over 3. Right? If it was pi over 4. Okay, so we're going to graph this one. And what about radius then? What about R? This is the origin. Right at the center is the origin. So if I'm going out, this is 1, 2, 3, 4. You see how that works? So if I'm going out, like along the pi over 3, it's 0, 1, 2, 3, 4. Okay? Now, all right, so let's graph 3 and 4 pi over 3. Remember, I do theta first. So 4 pi over 3 is this one. It's that line. And now I want 3 units. Where is 3 units? 1, 2, 3, right there. Now, your answer is just, if I erase this, your answer is just that point. All right, we're just plotting a point here. You could draw that line to direct you, but technically all I want is this labeled P. All right, what about the next one? It's negative 240 degrees. Where is negative 240 degrees? So if I go here, that's negative 180. Negative 240 is on the 120. And how much am I going to go? So it's the 120 here. And because it's negative 2, I'm going to go in the opposite direction, 1 and 2, and that's where my point R is. Okay? We're good with this? Okay. So in order to specify that point P, like to specify the location of point P, I could say, okay, that's at 3 comma 4 pi over 3. How else? Like, is there another set of coordinates that would get me to the same point? If you take a negative angle, if you add a 360, right? So there can be multiple representations of polar coordinates, right? So remember coterminal angles. You guys remember coterminal angles? So basically, if something has coordinates r and theta, then it also has polar coordinates theta plus or minus 360, theta plus or minus 2 pi. So I can take the angle, I can add 360 to it, and what happened? I just get back to the same point. I could subtract 360 from it, and I can get back to the same point. So let's skip ahead to example 3, and I'll show you guys a couple things here. So first we're going to graph P, which is at 2 comma 70 degrees. So 70 degrees is right past the 60, and if I go up 2, would that be a good place to put P? Yeah, I think so. Now, what if I took 70 and I added to that 360? What would I get? I would get 2 and 430, right? So where would that point end up? Right there. It's the same exact point. So what about 2 comma negative 290? What is that? Well, that's really 70 minus 360, so where is that? Same place. Oh my. Okay, so you can add or subtract 360 and you get to the same point is what I'm saying. Yeah. Well, because like this first angle was 70, right? And I'm showing you if you add 360 to it, you don't change the position of the point.
Oh, okay.
And if you subtract 360, you don't change the position of the point. Okay, now let's plot another one. 3 and 50 degrees. 50 degrees is right before the 60, and we are going out 3 units right there. So that's P. Okay? Now, what if, just for fun, I took 50 degrees and I added 180 to it? Okay? So if I added 180 to it, I would get 230. Now let me just graph 3 and 230. 230 is right there. 3 and 230 would be, that's 3 and 230, right? So what did I do? I started out from P. P was here. I added 180 and I got to that same point. But now, how can I get back to point P? Huh? Right. So if I just add 180, I get to this point in the bottom. But if I make it negative, then I go up right there. Right? Yes, that's what I'm saying. So another way to represent the same thing is you could add 180, but make the R negative. Okay? Another one is you can subtract 180, but make R negative, and you go to the same point. Okay? All right, so here we go. Here's a point S. Can you guys see where the point S is? Right, so here's a point S, and it says to find 4 different coordinates to name point S. The only thing is theta has to be between 360 and negative 360. So let's do the first one. The first one is just like where you see the angle, right? So R happens to be what here? It looks like it's 2, because it goes from the center 2 and 210. So that's the first one, okay? What's another thing I could do? Could I add 360? Would that work? No, because I would go over my bound. Can I say 210 minus 360? That would give me 2 comma negative 150, so that would work. Right? And is negative 150 between? Right? So what else could I do? Negative 2 and 30 degrees. How do we get 30? So basically we do 210 minus 180. And that gives us negative 2 comma 30. And what else? There's one more. What if I did 30, that new angle, minus 360? Right? So those are the 4 different representations. Okay? Questions? Okay, so we're gonna start graphing. Today we're only gonna graph the basics. Tomorrow's lesson is graphing the bigger equations. So what is a polar equation? Well, it's an equation that is expressed in terms of polar coordinates. So an example of a polar equation, right? R equals 2 sine theta. This is something that we're going to be graphing tomorrow, not today. Do we meet tomorrow? We do meet tomorrow. Okay, so the ones we're going to graph today are the basics. So if we were graphing in rectangular coordinates, let's say I had x equals 4, right? That's the most basic type of graph I could do, right? What does x equals 4 look like? It's just something that passes through x equals 4. It's a vertical line. Or if I wanted to graph, let's say y equals 3, right? The ones we're gonna graph today are the analogous ones to that stuff, okay? So here, we're gonna graph each polar equation. So look, a polar graph is the set of all points that satisfy a given equation, right? So look, let's plot a point that satisfies this equation, r equals 2.5. So let's see, 1, 2, 2.5. Would that be one that satisfies that equation? Yes, totally. What about this one? 1, 2, 2.5. Does that work too? What about this one? 1, 2, 2.5. Yeah, what is this going to turn out to be? This is going to be a circle, right? If I put in all of the points that satisfy r equals 2.5, it maps out a circle. Okay? Now, let's graph theta equals 5 pi over 6. Okay, that's theta equals 5 pi over 6. That's theta equals 5 pi over 6. So basically, what I want is a balance of 5 pi over 6, right? It's going to be a line. It's a line. Yeah. So now, if I had 5 pi over 6 with an r of 1, it would be here. With an r of 2, it would be here. What if an r of negative 2? It would be there. And negative 4, it'll be there. Okay? So that's that line. So basically, in rectangular coordinates, right, if I do x equals 4 or y equals 3, like just the variable equals a number, I either get a vertical line or a horizontal line, right? Here, if I do the variable equal a number, I either get a circle or a line. Okay? All right, polar distance. Okay, so take a look at this for a minute. Let's talk about the law of cosines. Okay, if this is A, B, and C, what's the law of cosines? A squared equals what? Do you guys remember? Yes. Minus 2AB cosine of A. And what's what's angle A? That's angle A. So angle A is the angle, I'm sorry, 2BC here. Angle A is the angle between B and C, right? Angle A is the angle between B and C. Okay, so it's the angle between these two that you're using in the formula. So now I'm just going to zoom in here a little bit. Okay, take a look at this. I want you guys to all please pay attention to what I'm doing here, right? Okay, so take a look at this one. You have one point to the left here, and if I draw a radius to that one, that's R1, right? And now I have another point here, and if I draw a radius to that one, that's R2, okay? So look at what I have now. Instead of A and B, I have R1 and R2. So here, I could do R1 squared plus R2 squared instead of B and C, okay? Now, what's the angle to R1? We're going to call that theta 1, okay? And the angle to R2, I'm going to call that theta 2, okay? Now, what I want though, remember here I said angle A was the angle between the two lines? Well, what's the angle between R1 and R2? What's that angle?
Theta 1 plus theta 2.
Is it plus?
Oh, no,
That angle is theta 1 minus theta 2. So this one, if I were to continue this formula, it would be minus 2R1 R2 cosine of what? Theta 1 minus theta 2.
Why is it 2R1?
That's just the formula. Right? That's the law of cosines formula. Okay, what if I messed up? Okay, so what if I messed up and I did theta 2 minus theta 1 instead? What happens? Okay, so suppose theta 2 was 70, theta 1 was 50. What's 70 minus 50? 20. What's 50 minus 70? Negative 20. Okay, so what if I had cosine of 20 versus cosine of negative 20? Nothing. Because it's a cosine, it makes no difference. Remember, cosine of oh my God, cosine of negative theta is cosine of theta. So you could have theta 2 minus theta 1 or theta 1 minus theta 2, and it doesn't make a difference. And it's important for me that you recognize that. More than knowing that formula under the square root, it's important for me that you recognize that the cosine is an even function. Therefore, the angle doesn't matter if it's positive or negative. So if all this, if all this was my distance squared, then the actual distance between them would be this. Do you have to memorize this? Yeah. Okay? Right. Just so we're on the same page. We're on the same page. Okay, so you have an air traffic controller tracking two airplanes flying at the same altitude. That's not cool, right? Because they could potentially hit. One of them is at 8 and 60 degrees. So if the radius is 8, I can count by twos. So this is 2, 4, 6, 8. So plane A is at 8 and 60 right there. And plane B is at 4 and 300 right there.
May I ask why you would graph that facility down?
Huh?
Why would you graph the facility?
What do you mean in a circle?
Why would you graph the facility this kind of
If you're in an air traffic controller, what are you looking at to see where the planes are? Right, but what machine are you looking at? A radar machine. And how does a radar machine look? So if it's sweeping, right? So if you see it in all the movies, right? If the aliens are coming or if the battleship is coming, you're here at the center. And if the battleship is coming and it's sweeping, first you see the plane there, and then it sweeps again and you see it there. And then it sweeps again and you see it there. So basically what's happening? The radius is getting close to you, right? The radius is getting smaller, so the plane is getting close to you. All right? Or, right, like if they're coming like directly at you, this is where you are. It sweeps once. It sweeps once, and you know the battleship is at A. It sweeps one more time, and then it shows it here, and then it sweeps one more time, and you're here. So this is how anything in like having to do with airplanes, it's all done in a polar coordinate system. Boats do it too, aeronautically. Okay, so it's all polar coordinate systems. Okay, so what I want now, first it says sketch a graph. There we go, we sketch the graph. So basically, to continue this is R1, this is R2, and the distance between them is this. Okay, so now it says how far apart are the two planes? Well, let's see. D is R1 squared plus R2 squared minus 2R1 R2 cosine. So how much was this? 8 squared plus 4 squared minus 2 times 8 times 4. Cosine of how much? 300 minus 60. And we plug this in our calculator in degree mode. Please, 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 please. I will not tell you to put your calculator in either mode, but you need to know, okay? How much? 10.6 miles, right. Right, so that's not really that far, right? 10.6 miles. So depending on which direction they're both headed, Okay, so that's that. And this homework will be due tomorrow, huh? Well, yeah, let's hope they're passing and not colliding. That'd be bad, that'd be bad, that'd be bad.